Okay, so this next lesson is for working with 3D tools for Mastercam Lathe. So let's go ahead and get started here. First thing I'm going to do is load the start file, which should be attached to this training segment. And so look for the download, and then you can just take that file and drag it onto the screen. That'll load the sample file. So this will give us a part to work with as we work through this training. So we're going to work with the 3D Tools feature in the Lathe Tool Manager. So we'll go to Lathe Tool Manager, and you'll see that there are no tools in this file. All we have is just a generic machine loaded for lathe. We have a lathe part, geometry, and a turn profile there to work with. And so we're going to work with the 3D Tool feature, which is located by right-clicking within the Tool Manager, Create 3D Tool. So we use the tool designer to create custom 3D lathe tools, which will result in a much more accurate simulation, finding collisions that 2D tools would not necessarily show. So the 3D tools also enhance backplotting and verification sessions. The designer comprises 9 pages of settings that cover every aspect of creating your 3D tool, from loading a step models to mating an insert to its holder, defining boundaries, setting mounting positions and cutting planes, and more. That's pretty much reading right from the help system within the Create 3D tool. So you can look at the help once we get into this feature and learn more about it. So I'm going to start off by clicking Create 3D tool. And so the tool designer pops up, and here you can, first off, it wants you to assign a name. So we're going to just call this Capto. And we'll assign this as tool 5. So we'll type in a 5 there and press the tab key, and 5 for the offset. We're going to work in inch units, and I'm going to be describing a right-hand tool. The step model for this tool is a right-hand tool. So you'll notice here's each of these different pages that we're going to sort of work our way through, and next down here would advance us to the next section. If you don't have enough information completed on a previous panel, you can't advance to the next. So it looks like we've got everything we need here. We'll just hit next. That's going to take us to the insert definition. So at the insert definition page, we're prompted to put in the model. So there's 2 ways to do this. We can get the model from an external file. That's the method we're going to be using in this example. There's also the ability to select a model that's already in the current session. We're going to be using select from an external step file. So currently the tool manager, the tool designer, only supports step file format. So we're going to select this. We're going to browse to the folder. Also, this particular Capto step file is part of the included downloads for this training segment. So we're going to pick that, and then I would like to make note here for step models. Let's hit the options button and make sure you've checked this attempt to heal solids during import. A lot of these 3D models of tools we found have inconsistencies in the model, and so this will heal and fix a lot of the various problems. So let's make sure we check that and hit the OK. Then we'll select that TCMT and Capto RH.step, and we'll hit open. So it's converting the model, bringing it into Mastercam. Right now I have shading turned off, so I'm going to hit Alt-S to turn my shading on. And you'll see we're being prompted here to select the insert model from the graphics window. So I'm going to come down here and just click anywhere on the insert. So you'll see how it separates that out and pulls up the insert. This is going to be for general turning. And then to get the radius, I'm going to type in the letter R and press enter. And then I'm going to come over and indicate this face. So it'll extract the radius of that face and put the value in. So that insert has an 0.31.5 corner radius. And so that pretty much completes everything on this panel. So now it does allow us to advance to the next. So we'll go next. And then next is to select a holder model from a file or the Solids Manager. So the same process, we're going to go over here and we're going to open the file selector here and pick the same file again. Now you'll notice if we hit options and we check this attempt to heal, that will already be checked. We're going to hit open. So it seems a little redundant in doing it twice, but the reason for those being separated is you might be bringing insert models in from one file and holder models in from a different file. So it really does make sense to have those separated. So then you're just going to click anywhere on the holder and hit end selection. And then Mastercam's going to separate that out. So you've got two different colors, the insert color and the holder color is automatically being assigned. So next you'll see that there's a field for manufacturer's code. There's also a checkbox for requires tool locator for machines that are fully defined for machine simulation in Mastercam. So you can check that to make sure that the system understands that that has to go in a locator. Then down below here, you're describing the shank, whether it's rectangular or cylindrical. In this case, it's cylindrical. A couple more things that we're going to do before we get any further on this. There's some optimization that can be done to make these models better and sort of run more efficiently in Mastercam, and can also solve some different problems. And so there actually are a couple of problems in this step model example that this will take care of. So I'm going to actually go back up to the insert, and we'll start with the corrections there. So on insert, you'll see there's a couple of buttons over here. One is called repair small faces, and the other is called optimize. I typically start over here on the right and click repair small faces and select the model. And pretty much at these defaults here, it'll tell you if there's any small entities found. So this is kind of looking for small faces, short edges, spikes, slivers, gashes in the model. And so, you know, it's looking like at these tolerance settings right now, it's not really finding any particular problems. You can try bumping the value up a little bit to see what the results are. So if we bump these up 1/1000ths, it says press preview to see results. If you press preview, it's going to take a second here. It's going to kind of give you some little markers sort of indicating where those problems are, and you'll see there's a list here. So just pointing this out, in some cases you kind of have to clean these up and let the system clean up and get rid of those potential problems. And so we're going to go ahead and hit the green check mark here. We'll let it clean this up. All right, then the second option here is optimize. So after cleaning it up for small faces or small edges, we're going to hit optimize. And optimize will then clean up the any other potential errors within that step model. It takes a minute to process. It comes back with optimizations made 24. So it made 24 optimizations to the model. And we'll move down and do exactly the same thing to the holder. So we're going to do the repair small faces first. It finds a few little problems. We're going to hit the green check mark, let it make those corrections. Then we're going to move over here to the optimize. That made 128 optimizations to the holder model. All right, so now those are all cleaned up. Now we'll advance on down further. So in shank definition, this is a cylindrical type shank definition. So we're going to hit the cylindrical option. And under diameter here, we're going to hit the letter D for diameter, press the enter key. We're going to come over to the model, and we're going to pick up the diameter of this edge. So you'll see this edge right here. We'll use that diameter for this particular style. So it has a 1.4042 diameter. And then we'll advance to next. So we're going to move down here. We're going to go to the mating options. Now mating has already been done in this case because this model of the holder with the insert came together as an assembly. This is in a case where you have an insert in one location and a holder in a different location, and this gives you the alignment tools to drop the insert into the holder. In this case, everything is already aligned, and in a future lesson, we can go through the mating process. In most cases, you'll be downloading a composite holder and insert, so it should be good on this panel. If not, you have the tools to make adjustments here. So next, we're just going to move right on past that, and we're going to go into the setup. So setup, the first thing is the cutting plane with a normal setup would be selecting the named plane top. But if you're working on a part that maybe is in a skewed coordinate system, or maybe your WCS is skewed to some other plane and or a location, you might set the cutting plane parallel to that WCS. So in this case, we're just going to work in top. The next thing you have to do is define the machine connection. And machine connection, you'll see is highlighted here. It says select the cutting plane and the machine connection plane. So second, we're going to do the machine connection plane. So I'm going to click this arrow, and I'm going to click this back plane here because this is where it basically mounts to the machine. So we select the machine connection. All right, so we're getting a little further along here. There is changing the up direction. So, in this case, you have the ability to flip that up or down. We're going to leave that as defined. And so we're going to right click and just go to Mastercam's top view, and you're going to start to see this tool definition really take shape here. First of all, you're going to see that it's applied this blue boundary to the outside of this. And so when we move to the next panel here, so this is set for top, there's no offset, it's set for the up direction is defined. The machine connection plane was defined. There's no additional offset there. And next we're going to move down to boundary. So if it comes up and it says boundary defined, that means it successfully has imprinted the profile, the 2D profile of this tool. So first thing I'm going to do is turn the shading off, Alt-S, and you can see this blue boundary and this yellow boundary representing the insert. So if we were to move this around and look at it, you'll see that it has applied a flat two-dimensional boundary at the in the XY plane. So that's a good sign. Now, if at any point at this stage, if you don't see that it has rendered this profile, try adjusting these tolerance settings right here, because if there's no profile, maybe a slight adjustment of the insert and or holder tolerance will all of a sudden make that boundary appear. So pay close attention to this boundary, turn your shading off, look for this boundary when you're at this point. There's also a couple of other settings here for just using the standard silhouette method versus using a silhouette from planes. And you can see from the little fly up help there that the planes option, if we pick this lower option, we have the ability to jump in and section the model for a particular section of it. And in some cases, if you're having troubles getting that profile created by sectioning through the model like this, you may have luck. So always try just the standard silhouette option first. And what you're looking for, again, is for Mastercam to come back and say that it is defined. And so if we are in standard silhouette mode and the result is defined, that means that you have two closed boundaries, one for the holder and one for the insert. All right, so back to Mastercam's top view. All right, so a couple more settings here. We're going to jump down to machine orientation. This is one of the most critical pieces. And machine orientation, the mounting position is set for vertical in this case for our example. And we're going to run off of a top turret, so we set that. we're going to tell it that the default active spindle is the left spindle and that the spindle rotation is counterclockwise. Now watch what the tool does when we flip that. So now we're looking at the back side of the tool from the operator's view to the machine. We're looking at the back side because the spindle rotation on a left spindle would be rotating counterclockwise. Therefore, the insert would have to be in the down position. So there's no tool angle mounting in this case. It's a straight radial mounting on this tool. And so everything is set there, and we can move to the next. So the next is the compensation. So we're going to zoom in on this tool a little bit here. So just roll your mouse wheel and zoom in a little bit, and then Alt-S to turn your shading off. The first thing it wants to know is the compensation point. And the compensation point for turning typically is the sharp intersection of where the insert nose radius is located. So the actual G-code coordinates come from this point right here and is all compensated in the software based on that insert geometry. So the first thing that we need to do is define the compensation point, and we can do that by selecting a couple of lines. We can set it from 3 different points on an arc, and then it's going to place where that corner radius of that insert is located. So it essentially will align the boundary to the radius that we picked up off of the model at the very beginning. So we can use this method where we're selecting 2 entities that is to be tangent to. So in this case, on this style of insert, there's a little bit of a flat here. So I'm going to pick this, and then I'm going to pick this line, and you'll see it's going to place that circle tangent to those 2 lines. So that puts us right in the correct spot, and we're making good progress here. So the method is corner. You'll see that in both the 2D tool description methods and the 3D uses corner, center, tip, or edge, and you'll see the 4 different examples there in the fly up help, and the one on the left is the more typical and is what we're using right now. So corner. Then you pick the quadrant. So this is the quadrant of compensation. So we're going to be running in the plus X quadrant and plus Z for the compensation. So we're going to pick quadrant 1, and then defining the plunge and feed direction. If you look, it usually makes a pretty good guess at this, but you can see the cutting direction is definitely this way. The plunge direction is that way, but you'll see you do have options to toggle that to the opposite solution. Next is tool clearance. Tool clearance, the first thing you want to do is set the side angle. So set the side angle here to maybe the clearance angle of the holder. So this is the side clearance, and this down here is the end clearance. So I'm going to set side clearance to this angle. And then next to this selector to select from line, you can manually key in the height value, but you can also use this select from arc to point option. And I can say, just pick this arc, and I want the clearance to be checked all the way up to this point. So from this circle, a line tangent, all the way up to here, we're going to collision check between those 2 circles. Now the same thing on your end clearance angle. End clearance angle, we're going to select from line. In this case, I'm going to use this portion of the holder. You can see that's a little shallower angle than the slope on the insert. And then for the width, we're going to use the circle point method. We're going to cursor onto this circle, and then we're going to come way over here to the end of the holder and pick this corner. Now we're going to gouge check or collision check from this circle all the way up to this circle. So that's a pretty good tool definition for this Capto. There's also a scan tool geometry, which attempts to kind of automatically set these settings. But I think in most cases, it's best to step through these steps and set everything this way. All right, so the final panel, we're going to hit next. And we're going to move into the set the feeds and speeds. I'm going to put this at 12 thousandths per rev. Plunge feed rate looks pretty good. 100% of feed per revolution. And then the spindle speed, let's put it 850 CSS. And then maybe amount of rough cut default to 150, finish at 10. And say that's all the parameters that we really care about at the moment. And then in coolant, we support two different coolant styles. There's the more basic standard coolant, and then you have your custom coolants in Mastercam. So in this particular style, I'm going to turn on through tool coolant, and I'm going to say before the operation gets started, we're going to get that through tool coolant running, and get that set up. So if you want flood on as well, you would toggle that on. And that saves those parameters in with the tool. So we hit the green check mark and the tool is in, defined. You get the nice profile and the name tool there. So you can right click on that at any point. You can go back into the create mode, or I should say the edit tool. And it'll take you back to these settings. I want to make one more change here where my tool name is a little more thorough. So I'm going to go to the insert and I'm going to highlight and grab this whole description here and then copy, move back up to the tool, right click and paste it there. So we have a better tool description. And then we'll hit the green check mark. Now we're going to try to apply this tool. So I'm going to hit OK. We're going to come over here to our geometry, Alt-S, turn the shading on, right-click. We're going to go into Lathe Tool Paths. We're going to go to Rough. We're going to chain from here all the way up to here. Hit the green check mark. We're going to scroll down. We're going to find our new Capto that we created. We're going to make that selection. You'll see the feeds and speeds come in. We'll just run with the default rough parameters. We'll tell it to use stock for outer boundary and hit the green check mark. So now we have our first operation with a new 3D tool that's been imported in. So if I go into my back plot, play through this, you're actually going to see the 3D tool in the back plot. If we go in to verify, hit verify. Same thing, we're going to hit play, get that nice solid 3D tool representation with full collision checking capabilities against the holder definition. Looks good. All right, now if we want to use that same tool again in another job. So for that example, I'm going to go up here to the Lathe Tool Manager, get back into the Tool Manager, close the simulation. So you can see our custom tool here that's in the current job. This window's the current library that we're looking at. So in this case, I just have the lathe inch default tool library there. But what I'm going to do is hit the create a new library. And in here, I'm just going to call this new library my new 3D tools. I'm going to make a brand new library here. So you'll see there's just an empty screen, but you'll see the data path and file name there. All I have to do is take that and drag it down and drop it into my new library. Hit the green check mark. All right, so we're going to go back and just to test this out, we're going to load this file again, the start file. So file, open, And the file name that we're looking for will be this 6807B-21 start. We'll open this file again, so don't save this one. So instead of defining the tool as we did last time, we're just going to get the tool from that library. So right-click, Lathe Tool Paths Rough, and we'll chain the geometry. Hit OK. So where we select our tool, we're going to go Select Library Tool, and then up here at the top, we're going to pick a different library. And I'll sort by date modified. That puts my new 3D Tools library at the top. I'm going to hit Open. There's my one tool. I'm going to hit Select it, hit the green check mark. I'm going to bring that in and basically go to my rough parameters, use stock for outer boundary. Everything's set to go. Bring it in and apply it. Go into the back plot. There's my 3D tool. Go into the verify. Let this load up here, and there it is again. So that completes the 3D tool designer for Lathe, and we'll continue on with the next lesson.